Algebra I 7.2c, multiply and simplify radical expressions. And of course, like always, I've got the previous videos. If you've missed them in this video's description, you could just click on them so you don't get confused. After we multiply radical expressions, we can easily simplify it by factoring. And remember from the previous video, we said that any expression that's simplified from an even root to an odd power, an odd exponent, requires an absolute value sign unless the expression is known to be non-negative. We also learned in the previous video that we could take the square root of 4 and the square root of 5 to equal the square root of 20. We can take that square root of 4, which is a 2, and put it in front of the radical sign for the 5 and get 2 times the square root of 5 equals the square root of 20. Okay, if you missed that, you can just click on the description and watch it real quick. So we can multiply and simplify. We've got the square root of 15 times the square root of 6. It's going to equal the square root of 15 times 6. We multiply 15 and 6 and get the square root of 90. That 90 can be factored into a 9 and a 10, and the 9 is a 3 times 3, so we can pull that out as a perfect square and get 3 times the square root of 10. Now we've got the square root of 18y times the square root of 14y. We can put them under one radical sign, and when we multiply 18 times 14, we get 252 here in the brown. So we have 252, and this y makes y squared. And if we do 36 times 7, we'll get 252. We'll be able to pull out a perfect square 36, y squared times the 7, and 36 y squared can be pulled out as a 6y, and that y is going to be in absolute value bars because we have an even root that we started with. There's an invisible 2 there, and we're going to an odd power, to a 1. And we multiply it by the square root of 7. So we've got 6 absolute value y times square root of 7. And take a look at this one. Now we've got a cube root. So we're starting with an odd root. And even though we're going to end with an odd power, we don't need absolute value bars because we're starting with an odd root, okay? So we've got the cube root of y to the 4th times the cube root of 16y to the 5th. We can put it all under one radical sign. And we get 16 times y to the 4th times y to the 5th. The 16 can be broken into an 8 and a 2 because we want to pull out a perfect cube. So 2 times 2 times 2 is 8. So that's why we pulled it out. And we can put these together as y to the 9th. Then we can rewrite it as 8 times y cubed to the 3rd power times 2. See? We just rearrange it with our commutative and associative properties. And now we can take this guy right here and put him under his own radical sign, and the 2 under its own radical sign. And because this is to the 3rd power, and that's a perfect cube, we can get 2y to the 3rd power times the cube root of 2. See? See how we regrouped the exponents and we pulled out that perfect cube? Okay, let's try another one. We've got 3 times the cube root of 25 times 2 times the cube root of 5. So we can multiply the 3 and the 2 together as a 6, and we put our radicals underneath the same sign, so we've got the cube root of 25 times 5. Well, 25 times 5 is 125, and the cube root of that is a 5, so we've got 6 times 5, which equals 30. See? Let's try another one. We've got the cube root of 3xy squared times the cube root of 36x. We can put it all underneath one radical sign. 3 times 36, x squared y squared. See how we put this x and that x together to get an x squared? And then we've got our y squared. 3 times 36 is 108. So we've got the cube root of 108 x squared y squared. We find a perfect cubed factor. That's 27. 27 times 4 is 108. So we've got 27 times 4 x squared y squared. we can pull this out as a perfect cube and multiply it to this one. This is 3 times 3 times 3, so we put 3 on the outside of the radical sign in front here, and we've got the cube root of 4x squared y squared. See? When we simplify. Let's try one last one. We've got the cube root of 18y cubed times the cube root of 4x squared. And put it all under one radical sign. And sometimes we can't pull out a perfect cube. We can still split it up into a 2 times 3 squared times y cubed times 2 squared times x squared. See? We're breaking it all up. Now, if you can see by the color coding, hopefully you're not colorblind. I feel sorry for you if you are, because I do a lot of things in color. I'm sorry. We've got our 2, our y cubed, and our 2 cubed here. And we can put them together as 2 to the third power, because we've got 1 here and 2 here, so that's 2 to the third power that we're going to put here. We've got our y cubed, which goes here, and our 3 squared and our x squared are going to go together over here. Okay, we rearrange them using commutative and associative properties. And now, because this is a cube over here, it's a 3, we can pull these out of the radical sign, can't we? So now we've got 2y times the cube root of 9x squared. See? Because 3 times 3 is 9, we got the x squared. See? When we simplify, all right? Now, if you're having trouble remembering factoring, because it was a couple chapters ago, I've got one video. I don't know if you remember it. In Algebra II, I'm going to have the link in this description. It's video 5.6, and it's every type of factoring all in one video. Okay, so if you already learned how to factor, but you're having difficulty remembering them because we haven't done it in a while, or you haven't done it in a while, you could watch that video real quick and you'll be right back on track. All right, and kind of use that as a, little extra help in your pocket. Okay, our next video is 7.3a, and we're going to find roots of quotients. I'm going to put this video in the Algebra II playlist. You can use it to study. There's going to be links to 11.3 and 11.4 from Algebra I when we talked about a lot of this. And those previous videos for Chapter 7, 7.1a through 7.2b that we did right before this, those links are going to be in this description, okay? So don't hesitate to click on that video 5.6 to review factoring. It'll really help you, okay? Because sometimes if you don't use it for a while, you end up forgetting it, right? And it just wouldn't hurt to do a quick little review, all right? Have a great day. I'm so glad you're watching YouTube videos for math, because it really shows good character on your part that you're trying to help yourself. And I'm proud of you. I'll see you next video. Bye.